a couple example problems that are at the end of Chapter 9. So here we're given a circuit. Everything's already in phasor notation for us, and we're just asked to find IS. So we have 5 ohms and J5 ohms in parallel. So I can start with that. 5 in parallel with J5. I'm going to skip a lot of the math that we have to come. I'll do this first part. 5 plus J5. You get J5 over 1 plus J. Again, I would just punch that right in your calculator at this point. The other option you have is to turn both of them into phasors because that division is easy. Do the division, then turn it back into rectangular. So again, using the calculator, you get 2.5 plus J 2.5. Okay, and then that is in series with this minus J5. So we can have 2.5 plus J 2.5 minus J5, or 2.5 minus J 2.5. And then that combination, all of those things, is in parallel with our 10. Oh, but I don't want to do that. That wouldn't be useful, would it? So let's redraw what we have right here. Redrawing is important so you don't do useless steps. So we have this 10 ohms here, and we have an impedance here. That is a combination of these three, or 2.5 minus J 2.5. And of course, that's still ohms. So we'll just call it Z. We don't care what it is. All right, so we can do current division to find out the current through there. You know what? This problem really sucks. That's okay. We'll keep doing it. It's a hard one. So current division to find this current, let's call it I2. The I2 equals the opposite one, 10, over the sum, 10 plus 2.5 minus J 2.5 times the source, IS. And if we reduce that down, we get 4 over 5 minus J IS. All right, so that's our current there. So that current will be here in this circuit, right? That's that I2. So if we look back at this circuit, we had this that was in parallel, carrying the same voltage, now in series with that. So let's redraw that one. It gets a little messy. So we have IS, we're backtracking a little bit, so our 10 is still there. We're putting our minus J5 back here, and we're just combining the 5 and the J5. When we did that, we had 2.5 plus J 2.5. And we have this current now, I2. And we have this voltage, V. So I can use Ohm's law, V equals IR, where the VO is my V, the I2 is my I, and the combination of these two is my R. So V equals let's say Z for impedance instead. Okay, so I have V, 8 angle of 30 degrees, equal I, it's this I right here, this I2, 4 over 5 minus J IS times my Z, which is these two in series. Right, wrong, right, wrong, I don't know, maybe. No, my Z is just this one. I'm getting myself all confused, right, because this current goes through here, I2. So I have the voltage, I have the impedance, I'm looking for the current. I finally got there. Okay, so the impedance is 2.5 plus J 2.5. So again, that looks very messy. The best thing to do is use your calculator on that. Again, if you don't know how to do phasors in your calculator, you need to look that up. It makes the next chapter especially a lot easier. So we do that, we get 2.88 minus 26.31 degrees amps. Also, if you don't have a calculator to do that, you can still do it, right? You just need to do quite a few steps in between here, turning them into phasors, doing the division, turning them back into rectangular, and doing the addition. It's not that it's hard, it's just labor intensive. All right, so there's that problem. Let's take a look at this other one over here. Let's switch to some orange. So we have this circuit, and we're asked to find our equivalent inductance, or our phasor inductance, our capacitance and impedance, the total impedance, and an I of t. So let's find our omega. Right here's omega t. So I know omega is 1,000. Go ahead and write radians per second. That means my ZL, J omega L, J times 1,000 times L, here, 0.5. So my ZL becomes J500 ohms. My C minus J over omega C minus J over 1,000 times C, 1 micro. That gives me minus J 1,000 ohms, or you could say kiloohm if you wanted to. So what's my equivalence? If these two are parallel in series with that one. So I have my resistor, 2,000, in parallel with the inductor, J500, and that whole thing is in series with my capacitor. So that's my equivalent impedance. And if you do the math on that, you get 542.3 at an angle of minus 77.44 degrees. Or we could write that as 117.6 minus J529.4. And now my I is V over R, or V over Z, impedance, V10 at an angle of 30 degrees, divided by my equivalence, 542.3 at an angle of minus 77.44. Divide these, subtract these, 18.44 at an angle of 107.5 degrees milliamps. But they asked me for I of t, so I need to write that in sinusoid form, 18.44 cosine omega t plus the phi milliamps. And that's your answer.